Creating tables and graphs are very important. What we do in science is how we organize and analyze data. Today we're going to be learning how to do this in a formal way, the kind of way that you'll be expected to use when you put these into a report, that is, tables and graphs into a report. In addition to that, this is a follow-up to the saltwater density lab. Okay, using computers in the classroom and cell phones in the classroom, there are some things you can do, things you can't do. Do's and don'ts here, okay? Accessing web pages that have nothing to do with this class. Not allowed. Okay, you can be written up for it. Using your cell phone to text during class. Not allowed. Okay? Not only is that distracting you from instruction, and I take pretty seriously the fact that I'm paid to teach. Okay? I can't do it if I'm competing with your cell phone. All right? With your texting. All right? Using your cell phone to access web pages, just like with a computer. Also not allowed. All right? There are times to use your cell phone. You can take pictures when they're appropriate, like lab equipment or something, or even the homework assignment. That's fine. I don't care about that. All right? In fact, some things are good to use that for. They're using this Google Drive system that we use in here. There's now a way to scan documents using your cell phone directly into Google Drive. And so there'll be a chance for you to use that to earn extra credit points. Okay? But we'll get to that when the time comes. All right? So any photos that I don't allow you to take, you can't take pictures of other students in here. Okay? Got it? Only the things that I tell you it's okay. All right, just ask. You know, sometimes lab equipment's fine. It's good to put it in there because you might want to show it on your lab report or something. Or, like I said, the homework assignments, or sometimes other things. But pretty much, texting, just not allowed. And any of these violations can result in you being written up for a failure to cooperate with your teacher. That's a pretty serious violation, but it's the only one available to me in the student handbook. You got that? So if I have to write you up, it's going to be for a pretty serious thing. I don't have any other choices. Got it? Anybody clear with that? All right, then let's go to your Google folder and talk about what you should have already done and where we should be now. So last night you should have completed where your name goes, the date, class period. You should have completed your procedures. We're not going to spend any time with that. We talked about replacing the label here, the description part of the table label. To reiterate, every table, and sometimes I won't provide a table for you. You have to create your own table. We're going to get to that point where you can do your own without me having to sort of handhold you through the process. Okay? These are like your training wheels. All right, when you learn to ride a bicycle to start with. Most of you probably started with training wheels, right? Yes? Okay, all right. So I'm sort of giving you a start by telling you and showing you this is what it should look like. You should have a table number on here. Okay, if it's the first table, it's table 1. If you got more than one table, you got table 2 and so forth, followed by a period. Capitalize the word table. Then you need a 1 to 3 sentence description of 1, what's in the table, and 2, why it's important. Okay? Don't skimp on this, all right? The idea, there's a balance here between being complete with your description and having too much stuff in there, all right? It's probably better at this point to have too much stuff in there than not enough. Okay? If you just say the minimum thing, you're probably not going to get all the points for it. Fair enough? What I did on the table itself is I already filled in this column label and this column label for you to give you a pattern to follow. Basically, column labels tell me what data or observations, and measurements or observations, we said, what data or observations are in that column, and the units of measurement go in the column label. There are no units of measurement in the cells where numerical data is placed. Okay? I gave you this first line right here. Okay, I gave you that data. Nobody had a lab table where they were determining the density of pure water. But roughly speaking, that's usually what you come up with, about 0.998. Really close to 1 gram per milliliter. Okay? You need to know and memorize the fact that the density of water is 1.00 grams per milliliter. Okay, I know it's slightly less than that. By the time you round it off, it's 1.00 grams per milliliter. Okay? If we go to the third decimal place, then it would be 0.998 at our atmospheric pressure at where we are in sea level and that sort of thing. Okay? And then we filled in all of this yesterday, yes? Didn't we? I just kind of missed Group 2's data that goes in here. Okay, so Group 2, what was the mass of salt water from your data? I just didn't get that put in there yesterday. Group 2, who's the captain? Okay. Well, while she's looking it up, somebody else could tell me. 49.97. Okay. And what was the, I think the next column was supposed to be the volume of the salt water, right? And that was? 46. Huh? 46.0. Okay. And then everybody was supposed to calculate density, yes? You need to open up the Logger Pro program. Go to the lower left-hand corner of your screen, click on the Windows icon, choose All Programs, and then choose the Vernier folder and double-click Logger Pro. And that'll bring up the program that we'll be using for data collection in this class. So titles of a graph are written like this. The effect of, and then you need a few words to describe what your independent variable is, on the, and then a few words to describe what your dependent variable is. That makes sense? You should have had that in your notes yesterday, and if not, I sent you the notes by email last night. Okay? Yes? Just be patient, keep working with it till you get caught up. Okay? Yep. What? This sign out screen? You can do a hard shutdown and restart if you need to. Yeah?
What do you do again to get to that?
Okay, you're going to find Logger Pro. So on your computer, in the lower left-hand corner is a Windows emblem, or it's called an icon. And you click on that. Yeah, I think you have to go to All Programs and find Vernier. Is that right? Is there an All Programs button on yours? Okay. And then you're going to find the Verniers folder, and then click on Logger Pro or double-click Logger Pro to open it up. Hopefully, if we started on it yesterday, did you save it on your flash drive? You could just open up directly what you already have on your flash drive. Okay? That's the beauty of having a flash drive. Okay? You can save stuff that you're not quite finished with. Now, there are places to save it so you can get back access to it. We haven't gotten that far yet. But the other side of that is, if you save it here, you can't take it home and work on it. And one of the things I'm going to do is I will send you, if not today, shortly, the access for you to be able to download to your home computer Logger Pro. So if you need to work on something at home, you know, your graph's not quite where it needs to be, you can finish it up at home if you need to. Okay? Because that's one of the things that Vernier does is it allows students to have free access to that program. We pay a license fee for you to be able to use it. Everybody good with that? Now, if I send it to you and you don't use it, that's just your choice, but I'm giving you that opportunity, okay? Now, is this your data or is this somebody else's data? This is third period's data, isn't it? Let's see what your data is. Let's go back here. I'm going to go to, where are we? Let's go. So your data are these two columns here. No, I don't have the density over here. It's supposed to be this column 1 and column 3. Okay? So column 1 was all this. So that's not the same. Did it paste it in there? Nope. Okay, what it did was, let's do this. For some reason, when I paste that first column, it doesn't give me the, I don't know, it's trying to skip some things or something. Well, I need to try it out with a spreadsheet and see how that works sometime, but this is not a spreadsheet, not quite the same thing. who's got the density for group 2? Have y'all calculated the density yet? Group 2, did y'all calculate your density?
Yeah.
What's your density?
1.0.
What? 1.009? Okay. Group 3, I'm sorry, that's that's yours. Okay. So group 2 then, that's group 1. Is that group, were you group 1? Group 2, so you're 1.09. Okay. Group 1, what's your density? Group 1, what's your density? Hold on a minute here. I need you to put your name on the top of this in pen, sign in, and put this in your personal file, okay? What
1.01.
what is it?
1.01.
1.01? Okay, and then we need to go to, so that's group 1, 2, we're ready to go to group 3. What's group 3's density? 1.05, okay. And what's group 4's density? 0.958. Uh-oh, that's a problem. Okay. And what's group 6's density? 5 density. Group 5.
It's 1.09.
Okay. And then group 6. Group 6, your density? Who's the captain for group 6?
1.107.
1.107. You didn't round off properly. You need to round off to 3 digits. Okay? All right. So, looks like group 3 and 5 don't have very good densities here because this should be a straight line. Pretty close to it. All right? So, we have to go with what you got, though, because we can't play with the data. All right? Your density should be over 1. So, it means what this means is the likelihood is that this data point right here, where I've got the marker on it right here, this data point right here is for, that would be group 2, wouldn't it? 3, 4, 5, 6. Yeah, group 2 and 4. Okay? So, this is group 2. This is the data that I gave you right here. All right, for no salt in the water. This would be group 1. That's group 2. And you can see it's kind of off this pattern here. Okay? That's called an outlier. And it means that you probably didn't have the best lab procedures. You made an error in your procedures. Okay? But we have to go with what you have because that's what you have. And this would be, let's see, that's 1, 2, 3. This is group 4 here. And you can see yours is way down here, and it really should be above 1 for sure. So if everybody did a really good job, we should have a straight line, and all these others are pretty much in a straight line. Okay? So you need to be careful in your lab procedures. You need to be careful that you do good work. It's always a good idea to run something like this more than once. Because then if you do it like 3 times, and 2 of them are pretty close together, and the 3rd one's way off somewhere, you know that you've got an outlier, it's called. All right, and you're probably going to go with the 2 that are close together and do a 4th test, and if you have 3 that are pretty close together, you know you got a pretty good number, and you take the average of the 3 that are close together. Does that make sense? But that does not excuse you from writing down the data on the outlier. It has to be written in your lab logbook, because if you don't write it down, you're lying. And science takes that very seriously. All right, here's what we're going to do. We're going to add a best fit line. That's what's called a best fit curve. But it'll be a straight line for us, okay, for this. So I want you to go up here and find this icon right here. I believe that's it. Curve fit, linear. Let's just go to linear fit. Curve fit will fit different kinds of curves. We're just going to click linear fit. And there's the linear fit for this data. Now it should be tilted up a little bit because better data would give you a straight line, more in line with what's there. Now the data's never going to fit dead on that line. Okay, if you have such perfect, beautiful data that all the dots fit on the line, you probably cheated. Okay? You with me? Everything, nature's just not that pretty and perfect. Everybody got a best fit line? You click right here where it says linear fit. Did you get that? All right, now what I want to do is, anytime you have a graph, you want your data to fill the screen or available space in the graph. So you notice we've got a lot of space here at the top where there is nothing there. Does that make sense? See what I'm saying? By the way, you can grab this box and move it around wherever you want to. Yes?
What icon thing would you click on the top of it?
It's linear fit. It's this one right here. Okay? So because I've got this space up here where there is nothing, I'm going to go over here to the left-hand side and watch my pointer change to this. You see how it changed that squiggly arrow with a line next to it? As long as I have it far enough on that axis, I can pull that axis up and sort of spread the data out so that it kind of fills the available space. Does that make sense? Yes or no? Yep. You can't find what? Did you save it on a flash drive? Well, you need to get a flash drive, and if you didn't save it on a flash drive, you don't have it. You got to redo it. You got to rebuild it. Okay. Yep.
How did you get your line to be like at that angle? Because mine, like it's at an upwards angle, but it's like zoomed so far out, I guess, that it looks.
Okay. Well, you can grab these little axes down here and move it around wherever you need to. So all your data is showing on the screen, and you can get it pretty close to that. Now there is an option. Let's see here. Is it there? No. Page. Insert. I'll analyze. Experiment. I don't know where the button is right off the top of my head. There is one that will auto fix it up automatically. Well, here's what happens with that is the data points will end up right on the outside line. I want them just inside the line. Okay? Everybody got the graph where they want it? Okay? When your graph's the way you want it, you're ready to put it in your report. Okay? When the graph's where you want it, you're ready to put it in the report. So I'm going to click on the white space around the graph, and you notice there's these little boxes right out here, these little boxes in the corners and halfway across the line here. Everybody see that? So I've highlighted the graph. Makes sense? Now you want the data in your graph to spread out over the entire available space. To do that, you need to be able to pull the data up or down, spread it out as needed. You see how to do that? Put your cursor over here along the outside edge of this vertical axis until you see that icon that has the squiggly arrow up and the bar at the bottom. Grab it and pull it up. And keep pulling it up that way until you get it spread out the way you want it. And then go back to the bottom and spread the bottom out. And you can do the same thing along the x-axis as well. The horizontal axis can be spread out the same way until you get your data spread out the way you want it. Now make sure this dialog box here, this box is explaining what the slope is and all those kind of things. Make sure that's not on top of any data points. Okay, when you save it and copy it. Okay. All right. So here's what we're going to do. Pay attention here just a minute. I'm going to right click on the graph. Well, I'm just going to click on the graph on the white space. I don't have to right click. Okay. I'm going to hit Control C on my keyboard. Let's see, where is my camera image? Here's my camera image. See if I can do this without it popping out on me. Okay. Control C. Okay. All right. When I do Control C, then I've copied that. All right. Then I can go to the report. Go down here where it says graph. Now we need to make sure the graph goes above that figure description, okay? Don't put it below the figure description, put it above the figure description. As it says figure 1 period, then hit, let's go back and I'll show you the camera again so you can see me hit Control, paste is Control V, okay? And Control V, and it's not pasting it. Oh, there it is. It's going. All right, it seems to be taking forever here, so I'm going to do this a slightly different way. Another way you can paste your stuff is to click on the graph. I think you can copy right here, right click, and then click copy, and then go back to your report, and right click and paste. That's another way to do it. So once we've copied the graph from Logger Pro, we're going to go back to your reporting document. And if you look down here where I've written the word graph for you, trying to help you out and get you a good start here, you'll notice there's a sentence here that says delete this sentence and replace it with a captured image of your graph. I'm going to highlight this right here, and then I'm going to paste my graph right in there. Okay, and there's the graph. Okay, and there's a graph suitable for a report. A graph isn't really suitable for a report unless there is a best fit line or curve there. So it has the properly labeled axes. The axis label has to explain what's in the graph and what the units of measurement are. What's in the graph and what the units of measurement are. So down here on the x-axis it says the mass of table salt in grams. And over here it says the density of salt water, of the saltwater sample in grams per milliliter. Remember the description of the title that I gave you, the effect of, tell me what the independent variable is. The independent variable always goes on the horizontal axis. So the effect of the amount of salt, or you could say the effect of the mass of salt. And then the remainder of the title is on the, and then you give me a description of what the dependent variable is. The dependent variable here is what is changed by adding that salt, and what is changed here is the density. So the title overall is the effect of the amount of salt on the density of salt water. Axis labels have to tell me what is being graphed on that axis, what that number line represents, and then also what the units of measurement are. In parentheses you say in whatever the units are, close parentheses. Same with the x-axis here. Both of those are there. Figure labels. Figure labels must have a figure number, and it has to say the word figure, capital F, figure 1, period. If there's another graph, that would be figure 2. A third graph would be figure 3. They have to be numbered in order, in the order they appear in your report. This is figure 1. And then you have to have a description of the figure that tells me 3 things. It tells the reader what's in the graph. That's number 1. Number 2 is why that information is important. And number 3 is perhaps the most important thing, and that's what the analysis is. So this best fit line of curve tells me the pattern seen in the data, the relationship between the x and y axis, the relationship between the independent dependent variable. That's the analysis in this particular case. So if all we're doing is showing how the independent variable is related to the dependent variable, then the analysis is going to tell me what the pattern of the data is. The pattern here is that as the amount of salt increases, so does the density increase. Now that relationship in this particular case, this kind of relationship, a straight line with a positive slope, is called a direct relationship. You need to know that. That's something important for you to include in your notes. You need to know that a straight line, positive slope is called a direct relationship. In a more detailed way, you might say it's a direct relationship between the measurements in my independent variable and the calculations in my dependent variable. So those 3 things need to be in a figure description. Every figure description has to have that. Now, having said that, we said that this particular analysis for a comparison of the independent dependent variable data is the analysis. There is another kind of analysis. If we created this best fit line and curve from this data for the purpose of finding out something else, let's say for instance I have a sample of salt water and I know its density is 1.08 grams per milliliter, and I want to find out how much salt was added to that sample to make that density. I would start over here at 1.08 and go straight over till I hit the line and then down, and I can find how much salt was added. In that case, the analysis is that the amount of salt added to 49.0 milliliters of water would be approximately, let's see, what would that be? About a little more than 7 grams of salt. That would be the analysis if that were the case. If the point of creating this best fit line of curve is to have a calibration curve, and that's what it's called. We create the curve, or we create this line for the purpose of analyzing something else. Then this line becomes a calibration curve, and that's what we call it. If that's the point, if we're creating a calibration curve to find out about something else, then the actual analysis is, what do we think that, or what do we expect, what is our analysis for the amount of salt dissolved in this case, whatever that is. It might, in this case, it's the amount of salt. It might be something else we're trying to figure out. And we use the graph for that purpose, to figure out how much of something there is, or what the value of something is from something else, using a calibration curve. So if we know the behavior of adding salt to water on the density, we can use that behavior, this best fit line or curve, to find out something else. We can make predictions about the future here. And that's what the benefit of having graphs is for. Not only does it tell you the patterns, but those patterns then can tell you about other things that we don't even know yet. So science, in a sense, in this case, can be used to predict the future. We can tell about some future density of some future solution if we put a certain amount of salt in the water. And so these things are all important in completing a formal table and graph. Okay? So to complete, now these are only parts of it. There's a lot more to a formal report. What we're doing is just some little parts at one at a time to help you get the idea behind reporting of what you need to report in a science paper. Don't forget to put your name at the top, the date, class period. If I don't have a title there for you, as I do here, you need to complete the title. Remember, your procedures are everything you planned in advance to do with any changes you made during the lab. And those changes should have been noted in your lab logbook, as should the original plan for what you were going to do have been noted and written down in pen in your lab logbook. You need to complete the table. The table label at the top has to have a table number. That's this right here. Table 1 period or table 2 period and so forth. And the description is defined here for you. What's in the table, why it's important. Column labels have to be completed. In this case, I've completed these 2 column labels for you. You're supposed to complete the last 2 and then fill in the data. Remember, no units of measurement in the data cells. Units of measurement go in the column labels, as I have done for you in these examples in these 2 columns here. And then you have to complete the graph. Cut and paste the graph after you've completed it in Logger Pro. Finish your figure label, and your report will be done. Okay, so in a graph, if you get a straight line with a positive slope, that's a direct relationship between the independent and dependent variable measurements or calculations. In general, we call those measurements or calculations data.